98% of the volcanoes on Earth are places you will never see erupt. They do not make the news. They do not evacuate cities. They erupt in total darkness, under crushing pressure, at the bottom of the sea, and they have been doing it, quietly, for longer than there has been land to stand on. Right now, as you watch this, roughly 1 million of them are scattered across the ocean floor. Most have never been seen by human eyes. And around a few of them, in water hot enough to melt lead, scientists found something that broke biology in half. We tend to picture volcanoes as mountains on land, coughing ash into the sky. But the truth is the opposite. The overwhelming majority of all volcanic activity on Earth happens underwater, unseen, along the seams of the seafloor. More lava erupts beneath the waves every year than from every land volcano combined. The ground you live on, the continents themselves, are the exception. The planet's real engine of fire runs in the dark, under the sea. Not fossils. Not survivors clinging on. Thriving cities of life, whole ecosystems, packed denser than a rainforest, living with no sunlight, breathing poison, feeding on the planet's own heat. Before this journey is over, you will stand beside a chimney of black smoke 200 meters taller than anything on land, meet an animal with a heart but no mouth, and watch an entire living world get destroyed and reborn in a single night. And at the very end, we will follow one of these vents to a conclusion that reaches all the way to the question of how you came to exist at all. We will get to all of it. But to understand why these places matter, you have to leave the light behind. Because everything you think you know about where life can survive is about to be proven wrong, starting the moment the sun disappears. This is a story about the single most important discovery in the history of ocean science, an animal that farms poison inside its own body, and a place that may be the reason you are alive to hear this at all. So take a breath. We are going down. Start at the surface, in the warm, bright water where almost all the life you have ever known exists. Then begin to sink. For the first 200 meters, there is light, and where there is light there is plenty. This thin skin of sunlit water holds nearly every fish you can name. It is the ocean's window, and it is astonishingly shallow, a sunlit film over a black abyss. Put the depth in perspective, because almost everyone underestimates it. The average depth of the ocean is around 3,800 meters, nearly 4 kilometers of water, top to bottom. That sunlit layer where all the familiar life lives is the top 200. In other words, everything you picture when you think of the sea, the coral, the dolphins, the schools of fish, the divers, all of it happens in roughly the top 5%. The other 95% is the dark world we are sinking into now. At 200 meters, the color drains away. Red vanished long ago, now blue is going too. This is the twilight zone, where the last photons die and photosynthesis becomes impossible. No plant can grow past here. No sunlight will ever touch what lies below. By 1,000 meters, it is over. Absolute, total darkness, the largest habitat on Earth, and the least understood. More than 90% of the living space on this planet is down here, in the cold and the black, and for centuries we assumed it was very nearly empty. And it is not just dark. It is cold, a steady 2 to 4 degrees Celsius, barely above freezing, everywhere on the deep seafloor. It is crushing, the weight of all that water pressing down with hundreds of times the force you feel at the surface, enough to implode an unprotected submarine like a soda can under a boot. And it is vast beyond comprehension, an unbroken night that covers most of the surface of our planet, and that we have mapped in less detail than the face of Mars. The only food in this whole enormous world is what biologists grimly call marine snow, a slow, ceaseless drizzle of dead things. Flecks of dead plankton, scraps, waste, the remains of everything that dies in the sunlit water above, drifting down for weeks to settle on the bottom. Down here, a single dead whale sinking to the floor is a banquet that can feed a patch of seabed for decades. That is how hungry the deep normally is. The logic was simple, and it seemed unbreakable. All life needs energy. On the surface, that energy comes from the sun, plants capture it, everything else eats the plants, or eats the eaters. No sun, no plants. No plants, no food. The deep sea, the reasoning went, was a desert of scavengers, living on scraps drifting down from the sunlit world above. For most of the deep ocean, that is roughly true. The seafloor is mostly cold, dark, and hungry, its scattered animals surviving on a thin snow of dead matter falling from above. It is a place of scarcity. And then, in 1977, a team of scientists in a tiny submarine went looking for something completely unrelated, and drove straight into the exception that would rewrite the textbooks. They were not looking for life. They were looking for heat. 1977, a ship floats above the Galápagos Rift, in the eastern Pacific, near the equator. The scientists on board are geologists, not biologists. Their theory, that the seams where the seafloor pulls apart should be leaking heat from inside the Earth. They wanted to find hot water on the bottom of the ocean. They sent down a submersible, a cramped metal sphere barely big enough for 3 people, descending 2.5 kilometers into the black. And when its light swept across the seafloor, the crew stopped talking. Understand what that dive was like. 3 people, folded into a titanium ball not much wider than a small car, breathing recycled air, sinking for over an hour through water that grew blacker and colder with every meter. Outside, the pressure could crush the hull instantly if it failed. There was no rescue possible at that depth. They went down on instruments and nerve, chasing a temperature reading. The instruments had already hinted something was strange. On an earlier survey, a temperature sensor towed near the bottom had spiked warm for a few minutes, then cooled, a flicker in the data that meant hot water was leaking somewhere down there. Cameras lowered blind had come back with frames full of clams no one could explain. So they went to look with human eyes. And what they found was not a warm trickle over dead rock. There was the heat they had predicted, shimmering water rising from cracks in the volcanic rock, the seabed itself breathing warmth. That part, they expected. What they did not expect was the crowd. Around the hot springs, packed onto the bare volcanic rock in the deepest, darkest, most sunless place they could reach, was an explosion of life. Clams the size of dinner plates. White crabs. And towering over all of it, forests of giant worms, longer than a person, tipped in blood red. The scientists had no biologist aboard and no way to properly preserve specimens. The story goes that they stored the first creatures from this impossible world in the only high-proof alcohol on the ship, the crew's vodka. They had sailed to study rocks, and stumbled into the biggest biological discovery of the century. The story of that moment has become legend in ocean science. The geologists reportedly radioed back to biologists on shore, describing clams and worms in the impossible dark, and the response was disbelief. This simply could not be. The people best equipped to understand the discovery were not even on the ship. It took a second expedition, with biologists aboard, to grasp what had actually been found, not a curiosity, but an entirely new way for life to exist. And when those specimens finally reached laboratories, the confusion deepened. The giant worm did not fit any known group cleanly. The clams were enormous and bizarre. Animal after animal turned out to be not just a new species but sometimes an entirely new branch of life, unknown to science. A single dive had opened a door onto a whole wing of the tree of life that no one had known was there. Because this was not supposed to exist. An ecosystem this rich, this dense, in total darkness, with no possible connection to the sun. Every rule said the deep sea was a desert. Here was a garden, blooming in the dark, around water hot enough to kill. The question hit them almost at once, and it was a profound one. If not the sun, then what is feeding all of this? The answer would turn out to be stranger than anyone guessed, and it starts with a smell. The smell of rotten eggs. The smell of poison. The water pouring from these vents is loaded with hydrogen sulfide, the chemical that gives rotten eggs their stench. To almost every animal on Earth, including you, it is a deadly poison. It attacks the very machinery your cells use to breathe. A few breaths of it in high concentration can kill a human being faster than most people realize, by shutting down the body's ability to use oxygen at all. It is one of the reasons sewers and mines have killed workers so suddenly for centuries. And down here, that poison is the foundation of everything. Because certain bacteria have a talent that changes the whole story, they can pull energy straight out of those chemicals. No sunlight required. They take the hydrogen sulfide streaming from the Earth's interior and, in effect, burn it, locking its energy into food. Scientists call it chemosynthesis, making life from chemistry instead of light. On the surface, plants run on sunshine. Down here, microbes run on the raw chemical breath of the planet. It is a completely separate foundation for life, one that needs no star at all. Sit with how radical this is. For as long as we had understood biology, there was one rule at the very bottom of everything: the sun is the ultimate source of all food. The grass, the deer, the wolf, trace any food chain back far enough and you always reached sunlight. Chemosynthesis broke that rule. It revealed a second, entirely independent tree of life, rooted not in a star 93 million miles away, but in the chemistry of the rock directly below. Two separate foundations for life, on the same planet, that barely knew the other existed. And the energy source is effectively limitless and eternal. The sun will burn out one day. But the heat inside the Earth, left over from the planet's birth and the slow decay of radioactive elements in the rock, will keep these vents alive for billions of years, with or without a sky. In a strange way, life around a vent is more secure than life in a meadow. These bacteria bloom around the vents in mats thick as carpet, so dense the rock disappears beneath them. They are the grass of this world, the base of the entire food web. And everything else you saw in that first discovery is here because of them. And these are not ordinary microbes. Some of them thrive at temperatures above 110 degrees Celsius, well past the boiling point of surface water, in conditions that would sterilize a hospital instrument. Biologists call them hyperthermophiles, lovers of extreme heat, and they sit among the toughest organisms ever found. Some vent microbes can survive doses of radiation, acidity, and pressure that would destroy almost anything else alive. The base of this food web is built from the hardiest life on Earth. Stranger still, these microbes are not only on the seafloor, they live inside it. There is a whole hidden world of them threaded through the volcanic rock beneath the vents, kilometers down into the crust, living in the pores of the stone itself. Some scientists estimate this buried deep biosphere could hold a significant fraction of all the microbial life on the planet, an entire living realm inside the rock, fed by the same chemistry that we cannot even see. Which brings us back to those giant redworms, because they are the strangest guests at this table, and they solved the poison problem in a way no one predicted. A giant tube worm can grow to over 2 meters. It has no mouth. It has no stomach. It has no gut at all. An adult tube worm cannot eat, in any sense you would recognize. So how does the largest animal at the vent survive? The red tip you see is not a flower. It is a gill, packed with a special kind of blood. That blood does something human blood cannot. It grabs hydrogen sulfide, the poison, and carries it safely, without being destroyed by it. The worm drinks in poison on purpose. And it carries that poison down to a special organ stuffed with billions of the chemosynthetic bacteria, living inside the worm's own body. The worm is a living garden. It supplies the bacteria with raw chemicals and oxygen. The bacteria feed the worm from the inside. Neither can live without the other. It is one of the most complete partnerships in all of nature. The tube worm did not find food in the dark. It grew a farm inside itself, and turned poison into a harvest. It is one of the most complete examples of partnership ever discovered, two utterly different forms of life, fused into a single body, each one useless without the other, thriving where nothing should. And it was not born that way. A tube worm larva does hatch with a tiny, simple mouth and gut, and it uses them exactly once, to swallow a starter dose of the right bacteria from the water around it. Then, its farmer safely installed inside, the animal seals the deal forever, the mouth closes over, the gut reshapes into the organ that will house the bacteria for life, and the worm never eats again. It spends its childhood recruiting its partners, and its entire adulthood being fed by them. Fed like that, they grow at a blistering pace, among the fastest growing invertebrates known, shooting up meters in only a couple of years to claim the best real estate closest to the flow. A bare patch of new volcanic rock can become a waving red forest, taller than a person, within a single human decade. There is nothing slow or fragile about them. Given heat and poison, they explode into being. Around the worms, the rest of the city takes shape. Ghost white crabs pick through the mats. Shrimp swarm in blind clouds, some have lost their eyes entirely and grown light sensors on their backs instead, the better to navigate the faint glow the hottest vents give off. Eyeless fish. Snails with shells of iron. Every one of them, directly or indirectly, living off the poison and the heat. Take that iron-shelled snail, because it is one of the strangest animals on Earth. Found near vents in the Indian Ocean, the scaly-foot snail armors its own foot and shell with plates of iron sulfide, literally building itself a suit of metal armor from the minerals in the vent water. It is the only animal known to use iron this way. Engineers have studied its shell for body armor designs. Evolution, in the dark, invented the metal-plated tank. Or the Pompeii worm, which builds a papery tube right against the hot vent wall. Its tail sits in water around 80 degrees Celsius, hot enough to cook an egg, while its head pokes into cooler water at the opening. It routinely endures one of the steepest temperature gradients of any animal on the planet, its own body spanning from scalding to merely warm, protected by a fleece of heat-shielding bacteria on its back. Every creature here is a masterpiece of the impossible. The density is what stuns biologists most. A hydrothermal vent can pack in as much living matter per square meter as a tropical rainforest. In the middle of the emptiest desert on Earth, the deep seafloor, these vents are oases so rich they seem to break the rules of the place they live in. And the structures they build are as extreme as the life they feed. It is time to stand at the base of one, a black chimney, taller than a skyscraper, growing before your eyes, spewing water that should not be able to exist as a liquid at all. They are called black smokers, and the name is almost right. The black smoke is not smoke at all, it is a storm of tiny mineral particles, metals dissolved out of the deep rock, crystallizing the instant the scalding vent water hits the near-freezing ocean. The water blasting out of a black smoker can reach 400 degrees Celsius. On your kitchen stove, water boils at 100 and turns to steam. Here it is 4 times hotter, and it stays liquid. The pressure 2 kilometers down is so immense, more than 200 times the pressure at the surface, that the water physically cannot boil. It is superheated, screaming hot, and still a liquid. Nowhere in your daily life does water behave like this. As those minerals crystallize, they pile up. Grain by grain, the vent builds itself a chimney of stone and metal, rising straight up from the seafloor. And they grow fast. Some black smokers climb tens of centimeters in a single day, faster than almost anything else made of rock on Earth. Watch one erupting and it genuinely looks like a factory chimney from an old industrial city, a dense black column pouring upward and bending away into the current, staining the water for hundreds of meters. Except this factory has no workers, no fire in the human sense, and it has been running since long before humans existed. It is the planet itself, exhaling metal into the sea, one crystal at a time, in perfect darkness. One vent complex in the Pacific, nicknamed Godzilla, grew into a tower 15 stories tall before it collapsed under its own weight. Picture that, a chimney of raw metal, as tall as an office building, standing in the black, gushing superheated poison, wrapped in a city of life, and no human eye had ever seen it until we sent machines to look. And getting close to one is genuinely dangerous, even for machines. The water at the mouth is hot enough to melt the plastic viewports of a submersible and soften its instruments. Pilots have accidentally driven robotic arms into the flow and watched their equipment warp and char. To take the temperature of a black smoker, early scientists pushed a probe into the throat of one, and it melted. They had to build new ones rated for far higher heat than anyone thought seawater could reach. Slice a chimney open and it tells its own history in rings of metal. The outer walls are cooler, porous minerals, the inner throat is lined with the metals that only crystallize at extreme heat. Each chimney is a chemical fingerprint of the exact water flowing through it, copper here, zinc there, traces of gold and silver locked in the walls. They are not just structures. They are the ocean floor mineralizing its own breath into towers of ore. Not all vents are black. Cooler ones, farther from the heat source, puff pale clouds of lighter minerals, white smokers. And one strange field in the mid-Atlantic, called the Lost City, builds ghostly white towers of a different chemistry entirely, up to 60 meters tall, powered not by volcanic heat but by seawater reacting with the rock itself. Its towers may have been venting, quietly, for over 100,000 years. There is a colder story here too. These chimneys are made of metal sulfides, copper, zinc, lead, silver, even gold, concentrated by the vents into or richer than most mines on land. Companies are already drawing up plans to strip mine the deep seafloor for them. Which raises a hard question we will come back to: what happens to a 2,000-year-old ecosystem when it turns out to be sitting on a fortune? And the vents do something for the whole planet that we are only beginning to appreciate. The entire volume of the world's ocean circulates through the hot crust at these ridges roughly every few million years, every drop of seawater on Earth, cycled through the fire and chemically rewritten. The vents help set the salt balance, the metal content, the very chemistry of the sea. These are not just curiosities on the bottom. They are one of the organs that keep the ocean the ocean. They move heat, too. Each vent sends a plume of warm, mineral-laden water rising hundreds of meters into the abyss, feeding slow, deep currents that stir the entire ocean over centuries. A single black smoker is a tiny thing against the size of the sea, but 65,000 kilometers of them, burning without pause, become a force that helps drive the circulation of the whole planet's water. But the vents guard one more secret, and it is the deepest of all. These oases are not permanent. Each one lives, and each one dies, and what happens when a vent shuts off reveals the most extraordinary survival story in the ocean. A hydrothermal vent is tied to the plumbing beneath it, the cracks in the volcanic rock that channel hot water up to the seafloor. And that plumbing shifts. An eruption can reroute it. An earthquake can seal it. Slowly or suddenly, the hot water stops. And when the heat dies, the whole city dies with it. The bacteria starve. The tube worms, cut off from their chemical fuel, wither. The crabs and shrimp scatter or perish. Within months, a thriving metropolis becomes a graveyard of empty tubes and bare rock. An entire world, extinguished, because a crack underground moved a few meters. Divers returning to a dead vent describe it as genuinely haunting, the pale skeletons of tube worms still standing where the forest used to wave, the cold chimneys crumbling, a silence where there had been a teeming crowd. An oasis that took decades to build can be gone in a single season, leaving only a ruin on the seabed as evidence that anything ever lived there at all. In the deep sea, a paradise is always temporary. But here is the miracle. Somewhere else along the ridge, kilometers away, sometimes much farther, a new vent breaks open. Fresh hot water, fresh chemicals, fresh bare rock. And within an astonishingly short time, life arrives. Bacteria first, then grazers, then, unbelievably, the giant tube worms, colonizing brand new ground. This is the puzzle that consumed scientists for years. The adults cannot move. So how does a species that lives only at vents, isolated oases scattered across thousands of kilometers of empty seafloor, cross the desert between one dying home and one newborn one? The answer is that they gamble on their children. Vent animals release vast clouds of tiny larvae into the water. Most drift into the dark and die. But a few, carried by deep currents, happen to sense the faint chemical signature of a new vent, and settle, and grow, and build the city again. Every vent community is a colony of pioneers, descended from a lottery-winning handful of larvae that found a new home before their old one went cold. Some of those larvae can drift for weeks or months before they land, riding deep currents for hundreds of kilometers, in a kind of suspended animation, waiting to sense home. It is a staggering gamble against the odds. The deep sea is enormous and the vents are pinpoints in it, and yet it works, generation after generation, because the parents send out not a few children but millions. It is reproduction as a lottery played on a planetary scale. This turns the whole mid-ocean ridge into a chain of stepping stones. A species survives not by any single vent lasting forever, none of them do, but by there always being a new one opening somewhere within reach of the drifting young. The community is immortal even though every individual city it lives in is temporary. It is less like a town and more like a campfire passed from hand to hand down an endless dark trail, never the same fire twice, never going out. Scientists have actually watched it happen. In 1991, researchers arrived at a Pacific vent field just after an eruption had paved it over with fresh lava, the community incinerated, wiped clean. They kept coming back. Within months, bacterial mats bloomed. Within a few years, the tube worms had returned in force. They had front row seats to the death and complete rebirth of an entire ecosystem, something no one had ever documented before. The first sign of rebirth is eerie. Before any animal returns, the fresh lava erupts in a blizzard of white, vast blooms of bacteria so thick they billow off the rock like a snowstorm, some blasted up from cracks where they had been living inside the crust all along. Scientists call this the snowblower effect. The seafloor appears to be smoking white, seeding the water with the microbial grass that everything else will feed on. Life does not creep back timidly. It erupts. By returning to the same coordinates year after year, researchers turned a patch of seafloor into a time-lapse of creation itself, bare black glass, then white bacterial fields, then grazing snails and crabs, then the first small tube worms, then the towering red forest, an entire wilderness assembling from nothing in less time than it takes a pine forest on land to reach waist height. Nowhere else can biologists watch a whole ecosystem be born from scratch. Think about what that means. These are not fragile relics barely hanging on. They are among the most resilient ecosystems on the planet, built to be destroyed and to come roaring back, over and over, riding the pulse of the restless seafloor. Life here does not merely survive catastrophe. It depends on it. And they are everywhere. Since 1977 we have found these communities along the mid-ocean ridges that wrap the entire planet, a volcanic seam 65,000 kilometers long, the longest mountain range on Earth, almost all of it underwater. We have explored only a tiny fraction of it. Every expedition finds new vents, new species. The deep sea is still, today, the greatest frontier of discovery left on this world. Think of that ridge as a single wound running around the whole Earth, endlessly leaking heat and chemistry, dotted with these oases like campfires along a mountain trail 65,000 kilometers long. We have visited only a scattering of the campfires. Most of the trail has never been seen by anything with eyes. There are almost certainly whole categories of vent life out there, animals, partnerships, chemistries, that no human has ever imagined, waiting in the dark. The numbers back that up. Since the first discovery, scientists have described hundreds upon hundreds of new species from vents, the overwhelming majority found nowhere else on Earth. Roughly a new vent species has been named every couple of weeks, for decades. We are, right now, living through the single greatest wave of animal discovery since the great naturalist voyages of the 1800s, and it is happening in the dark, at the bottom of the sea, largely unnoticed. Which leaves one final question, the biggest one. If life can begin from nothing but rock, heat, and chemistry, with no sun at all, then maybe the vents are not just a place life survives. Maybe they are where it started. Rewind 4 billion years. The young Earth is a hell of molten rock and endless meteor strikes. The surface is bombarded, irradiated, scorched. There is no ozone layer. The sun's raw ultraviolet would shred any delicate chemistry exposed to it. The surface is the most dangerous place on the planet. But at the bottom of the sea, around a hydrothermal vent, it is calm, sheltered, stable. There is a constant supply of energy from the Earth's interior. There are the raw chemical building blocks, concentrated and flowing. There are tiny mineral pores in the rock that could act like the first cell walls, holding molecules together long enough to react. For a growing number of scientists, this is the most compelling setting we have ever found for the origin of life. Not a warm little sunlit pond, as Darwin once imagined, but a deep, dark vent, where the chemistry of a restless planet could assemble the first living things in the shelter of the abyss, protected from the violence above. And the evidence runs deeper than logic. When biologists trace the tree of all life back toward its root, past plants, past animals, past almost everything, the organisms nearest the base are heat-loving microbes that thrive in exactly the scalding, chemical-rich conditions of a hydrothermal vent. Our oldest known relatives look remarkably like the things that still live in the smoke today. Scientists even have a name for the single ancestor at the very bottom of that tree, the one cell that everything alive today descends from. They call it LUCA, the last universal common ancestor. And when researchers reconstruct what LUCA's genes were built to do, the portrait that emerges is startling: an organism that lived in hot water, without oxygen, feeding on hydrogen and metals and the chemistry of the rock. In other words, the common ancestor of all life on Earth looks exactly like something that would feel at home at a hydrothermal vent. There is an even deeper clue, hidden in your own cells. Every living thing powers itself using tiny gradients, differences in charge across a membrane, like a microscopic battery. It is a strange, specific trick, and every organism on Earth uses it. A hydrothermal vent produces exactly that kind of natural gradient for free, across the thin mineral walls of its pores. Some scientists argue life did not invent its battery, it inherited it, from the rock, at a vent, 4 billion years ago, and has never stopped using it since. Follow that line forward, and it runs through every living thing, through the microbes, through the fish, through the first creatures to crawl onto land, all the way to the animal watching this screen. If the vent hypothesis is right, then your very distant ancestors were born in the dark, breathing poison, warmed by a volcano at the bottom of the sea. You are, in the deepest possible sense, descended from these places. And that idea reaches beyond this planet. Because moons like Jupiter's Europa and Saturn's Enceladus hide oceans of liquid water beneath their ice, and there is good reason to believe hydrothermal vents are venting into those hidden seas right now. If life on Earth began at a vent, with no need for sunlight, then the same thing could be happening, at this very moment, on a frozen moon hundreds of millions of kilometers away. When we finally send a submarine beneath the ice of Europa, we know exactly what to look for. We found the blueprint at the bottom of our own ocean. Which makes the last part of this story urgent. Those metal-rich chimneys are worth billions, and the machines to harvest them are being built. We may start strip mining the deep sea floor before we have even finished discovering what lives there, destroying ecosystems, and possibly clues to our own origins, that took thousands of years to grow and that we have known about for less than 50. The damage would not stop at the vent itself. Deep-sea mining machines throw up vast clouds of sediment that drift for kilometers through water that has been perfectly still for millennia, smothering filter feeders that have never had to cope with a storm. And because these animals grow so slowly at the edges of the vent fields, and live nowhere else on Earth, a single mining operation could erase species we have not even named yet, extinction before discovery, on the floor of our own planet. There is a live global fight over whether to allow it at all. Some nations and companies are pushing to begin, scientists and conservationists are pleading for a pause until we understand what we would be destroying. It is a strange, modern kind of decision, whether to strip mine the possible birthplace of life, for metals to build our batteries, before we have finished reading the story written on the seafloor. We have known these ecosystems for less than a single human lifetime. They have been here for 4 billion years. We spent all of human history believing life needed the sun. Then, in a single dive in 1977, the ocean showed us a second way to be alive, older, tougher, and stranger than the one we knew. A way that may have come first. A way that may exist on other worlds. It is worth pausing on how recent all of this is. Human beings have gazed at the stars for tens of thousands of years and named every one we can see. But the discovery that there is a whole second kingdom of life on our own planet, running on chemistry instead of light, that is younger than many of the people watching this. We found an alien biosphere, and it was not on another world. It was at the bottom of our own sea, the entire time, waiting in the dark for us to build a machine brave enough to go and look. The next time you look at the sea, remember what it is hiding. Beneath that surface, in the cold and the dark, 1 million volcanoes are burning, and around them, in water that should kill anything, the oldest gardens on Earth are still blooming, exactly as they have for 4 billion years, with no need for the sun, or the sky, or us. Somewhere down there right now, in absolute blackness 2 kilometers below the nearest wave, a forest of red-tipped worms is swaying in a current of poison, tended by bacteria, warmed by the raw heat of the planet's core. No one is watching. No sunlight has ever touched it. And it does not need to be seen to be one of the most extraordinary things in the known universe, a second Eden, blooming in the dark, that has been here far longer than we have, and will remain long after we are gone. If this journey changed the way you see the ocean, stay with us. The next descent goes to the single deepest point this planet has, and to the creatures that call the bottom of the world their home.